Thank you all for coming. In the next 50 minutes or so, I'm going to tell you all how exactly to build a wildly successful enterprise application using Google Cloud Platform. I'm Greg Hutchins. I'm an engineer in the cloud organization at Google, but I don't actually work on Google Cloud Platform. Instead, my team and I have spent the past few years building an enterprise application exactly as if we were an external team, using just the publicly available features, services, and everything of Google Cloud Platform. So if you're going to build a wildly successful application, first you have to decide what to build. Cloud Platform is not going to really help you here. For us, we actually almost stumbled upon this, is that we were trying to grow our team, we had to hire people, and everyone we talked to kind of had horror stories about how that had worked in their past at other companies. It was really everyone. It was from the candidates to the recruiters to the employees at the interview to hiring managers. And so we said, oh, let's build this little prototype just to manage this process and make it better. We won't spend much time on it. It's not that interesting. So we built the prototype, started using it, and the more we dug into that space, we realized, oh, this is kind of interesting. Like hiring is something every company has to do. It's a critical business process. And so from that, we said, well, let's actually make this prototype our product. And we dove right in. So for you, choose something. Please don't choose hiring. So what did we build? We called it Hire. Super descriptive. And what does Hire do? It manages the entire process of finding new employees, from sourcing to job postings to scheduling interviews to adding feedback to kind of basically hiring the person. And we integrate with all of the kind of the tools in G Suite you already know and love, like Gmail, Calendar, Sheets, Drive, Docs, etc. And actually, even now, we're starting to add some more kind of AI-powered features, which I'll talk a bit more later. And are we wildly successful? I'm maybe not the best person to judge this, but we launched roughly a year ago, and since then, at least according to some industry press, we're the #1 growing app in the space. And beyond just customer growth, we've got a wide breadth of customers in different industries, from retail to like health to restaurant to construction, and I guess a little bit in tech as well. Beyond just that also is our customers seem to like us. We run these little surveys in app, which we call happiness tracking surveys, which are basically customers give us thumbs up or thumbs down, and we get mostly thumbs up. So we've built a wildly successful application. How did Cloud Platform get us there? So normally when you're choosing what cloud to use, it's between Google, and I think there's 2 other big names that come up, which I can't quite remember right now. But for us, we're actually a team at Google, and Google already has like the best internal cloud in the world for building, deploying, and maintaining global scale services. I guess I'm not biased there. But so why aren't we using the internal cloud at Google? And there's a number of reasons. First off, the internal cloud is like notoriously difficult to use. People talk about if you have a new employee comes on, it's going to take them 6 months before they're useful. And beyond that, also people joke about that once you've actually come up to speed, if you want to use anything, all the other services internally, they're either currently in beta or already deprecated. So if you're building something, you're first to choose between something that's beta and buggy or something that's deprecated, and you're going to have to switch to something new in a little while anyways. Cloud Platform, on the other hand, is stable, documented, public. You can actually hire people with experience. It's got a coherent user interface, coherent command line tools, all sorts of things to recommend it. None of those are the real reason. The real reason, it's dog food. Dog food. Okay, people don't say that. But here at Google, we talk a lot about dog fooding and eating your own dog food. This is actually an industry term, I believe. You can look up the Wikipedia page. But what this means is you basically volunteer or force your employees to use the software that you're building. And as the name implies, this isn't always that pleasant of an experience. Even here in San Francisco, where the dog food's free range, organic, asbestos free. But so what we did is for Hire is that we built Hire. We've been using Hire since basically day 0 to hire everyone. And that means our first set of users are people right down the hall where they can go yell at you and say this feature doesn't work, there's a bug, I don't understand why you did this. And you can use that feedback to make things better. And I guess very seldomly they'll tell you this feature is awesome. It doesn't happen much. More than this, though, is that our entire Hire product, is we're building it as if we're external. So we're actually doing a dog food of all of Google Cloud Platforms. We're building an application, just like you guys are building applications. And then we can provide, hopefully, trusted, coherent feedback to the cloud platform team about what works, what doesn't work, et cetera. And this dog fooding process is really, really important. And if you're building an application that you're not dog fooding, think about building something else. Yeah, so eat your own dog food, it's good for you. And now on to how we built the dog food, like what did we use in Google Cloud Platform. A little bit first about like higher architecture. We're actually really pretty standard enterprise app. We're built on something I call the Sean stack. I'm pretty sure no one else in the world uses that. It's basically the mean stack, which is Mongo, Express, AngularJS, Node.js, where we've swapped out Mongo with Cloud Spanner. You can see the diagram here is pretty standard. We have web browser, we're using AngularJS, mixture of JavaScript, and we're now moving to TypeScript there. Packaged up everything there with Webpack, which we love. And we're talking to various Node.js app server backends. Those backends spend all their time either writing stuff to Spanner or cloud storage or making basically API calls to like the public Gmail, Docs, calendars, et cetera. Step up. This is a place like source control. You have to pick something here. Google actually has this amazing internal system. We've written papers on it. It's called Piper. It does the whole source control, code review. I guess you say repository management and tests as well. Unfortunately, we're acting as if we're a third party, so we can't use any of that. Instead, we chose Git, everyone's favorite source control system. My thing I like about Git is that if you can figure out how to use Git, it makes actually writing your application seem easy in comparison. You think I'm joking, but I'm not. It's my favorite Git man page. As far as for our repository management and code review tool, we use something like Garrett. I believe that was spun out of Google many years ago. For a while, I used to complain how much worse than GitHub it was. I actually kind of like it now. It's under active development. It's open source. It's rapidly getting better. And then beyond just this, even though we're using different tools, we're still following the standard Google code review policies. Every change gets code reviewed. Everything is tests. Speaking of testing, I said we have a homegrown test infrastructure. Totally don't do this. It takes lots of time. And when we were first starting out, we evaluated everything out there with third parties. And at that time, Cloud Platform was relatively new. There was nothing we really liked, so we went off and built our own. Now, I think, like today, I think the Cloud Build was announced. Definitely look at that. And I believe all the third parties at this point support Cloud, Google Cloud. But for us, what we have, we're actually pretty happy in it. Anytime you push a code review, it gets tested, and you get your results back in 30 minutes or less. We run basically our entire test suite, which is right now, I think 1,500 tests, or 1,500 suites, 20,000 test cases. And I really test this. Don't tell anyone, but I often make code changes without ever running them locally, as if our tests pass, it's good. And that's pretty much works out. And yeah, again, don't do this, use a third party. But if you do this, there's lots of things here that Cloud Platform has helped us, is that all of our artifacts for all of this are stored in cloud storage. So this is like the test runner logs, the app server logs, for our kind of end-to-end browser tests, we actually record videos of where we click. And so if you have a front-end test that's failing, you can just click that video and watch what's happening. The other piece we use a lot here is we're using BigQuery. I'll mention that a lot today. We really love BigQuery. And so all the test runs, the results goes in there. We can figure out which tests are flaky, automatically rerun them. And then also for scheduling, we want to run our longest tests first. And so that's also in BigQuery. The other thing we like is we use preemptible VMs to keep costs down. And here's a quote from basically the engineer that built all of this, and his quote was, "Don't use preemptible VMs." And really what he meant was that we had a system that was built without preemptible VMs, and when they came out, we said, oh, let's just switch to those. And retrofitting them turned out to be really hard, is that the number of new failure modes it added, it just took us a long time to get back to stability. But definitely, if you're starting from the beginning, definitely use preemptible VMs. Other thing is maybe a theme here is definitely read the documentation. The exact quote from the docs are, preemptible instances are excess compute engine capacity, so their availability varies with usage, which does mean that if you're using only preemptible VMs, at any point they may all go away. And that did happen to us once. It hasn't happened recently, but it's just something to keep in mind. Luckily, it's really easy. It's a single flag to switch back to regular VMs. So we've talked about testing, how to actually deploy things. I actually tried to draw a picture of what our release process looked like and started looking like one of those diagrams from a serial killer movie where you've got pictures and string and all of that. So instead, I just put that picture of the canary here. So I'm going to try to explain this verbally. But basically, we do push code daily to prod, but we only release features to our customers monthly. What this means is all feature work is hidden behind essentially runtime flags. Is we've got a table in our database that lists whether or not a feature is enabled for a certain individual user, a customer, or for everyone. And this breaking up your code releases, your code pushes from your releases makes things so much simpler. And how do our code releases work? Is kind of how our code pushes work is basically I make a change, it gets pushed up to Garrett. We run our tests automatically run on it, say thumbs up or thumbs down. Colleagues do code reviews, thumbs up or thumbs down. It's usually a few thumbs down until thumbs up. At that point, we check it in. Next day, it gets deployed to our staging system, which is basically an exact copy of production with some minor configuration changes like different crypto keys and that kind of thing. And then we do manual testing there. And then the next day, it gets pushed to what we call our canary set of customers. That's the picture. And those are basically the customers we randomly selected that get to try out new things. And if there's any problems there, we stop and roll back. We do the same thing for our monthly feature releases, is that some features are obviously in development for many months, and so we actually have a longer rollout process for those. Is our dog food feature, we first roll out to our dog food tenants, which is basically our use of hire, maybe our sales demos, and a couple other things. Next, if it's a big feature, we might roll out to what we call our trusted tester customers, which is a set of customers that have agreed to have beta features, and they'll give feedback and may stay there for months. And then after that, it kind of follows the same process as our code pushes. It goes to the canary, and then usually the next day to all customers. And all these different, like we have this production, I mentioned staging. We also have performance environments, where a set of environments that we have simulated really large customers and are running performance tests. All of these different configurations are all almost the same but different. And this is one place where our cloud platform really helps us. We have all of our config is checked into our code system, and I'll talk more about that later. It's basically our release process. So what do we use in cloud platform to build our wildly successful application, and what do they help? And there's lots of things we've used. I'm just going to cover the big ones here. All right, this is kind of a tired analogy. It's the cattle versus pets, and I think people like me include it here just to give a break, and we can all admire the cute animals. But what this means, if you're not familiar with this, is in the bad old days, we used to treat servers like pets, is that you'd give them a name, you'd hug them and care for them, and if one of them got sick, you would take it to the vet and make it better. Nowadays is, yeah, don't do that. Treat your servers as if they're cattle, they're interchangeable. And how do you do this? This is where like Kubernetes engine. We're basically all on Kubernetes at this point. And what's nice about that is you can have all of your configuration basically checked in. And if it's checked in, you can do code reviews on the configuration and then run tests, and we do that. And I'll talk about this later more, but like configuration changes are really dangerous as far as running a service. And another nice thing, if you're not familiar with Kubernetes, is the configuration isn't like a set of steps, things to deploy. It's a description of what your environment should look like. And so you can start doing things like self-healing on this, diffing it when you make a change, all sorts of really nice things. It took us kind of quite a while to get there. And I think our first version here was just a set of shell scripts where we're making like cloud API calls. And then we switched, okay, let's use deployment manager configs. We had those checked in at that point, and we were using Google Container Engine for that, Compute Engine for that, sorry. And this all worked fine. We were kind of unhappy with this. Our resource utilization was bad. Things like rolling updates, we were having trouble getting them to be as fast as we wanted to. And our configuration was starting to get messy, and so we wrote like a templating tool for that in, I guess it's Python this time, and that helped a little bit, but we were still making mistakes that we didn't think we should. And so about that time, the Kubernetes came out and was in production, so we switched over to that. And this was great. We got all the benefits, as our rolling updates were fast, our system was more stable. Our config files were still we had checked in YAML files, and they were still kind of big. And so we were having problems where people would update a staging environment and then forget to update the production, so it was error prone. We wrote actually a templating tool there. We used Go, I guess because you have to use all the languages. But that was, so it's kind of still a problem. And so this year we switched to something called JSONet. This is another open source project inspired by features of the Google internal cloud. We haven't been using this for long enough, but so far it's so happy. Our configuration files are smaller. It's still checked in. And we're using basically this for all of our Kubernetes config. We have a little bit of deployment manager still. As far as like what in Kubernetes do we use, we have a pretty straightforward setup here. We have, I think, one cluster, a couple node pools, a handful of services. So not terribly interesting. We are using, like we love the rolling updates we get for new changes. I was talking to people, we're actually not really using auto-scaling very much. That's probably because we're at Google and we never actually get the bills. I know that's on our list of things to fix, but I was a little surprised to figure that out. Yeah, so as I said, we're mostly on Kubernetes. We have a couple of cloud functions we're using. They're super easy to spin up. I'm a little like anxious of these because maybe one of the first ones I used is I didn't read the documentation. See that theme? And there's like a 10 megabyte serving limit, and so our customers grew, and we were like merging XML files for a job feed, and that went past 10 megabytes, and we got an outage. So I'm still a little scared of them, and maybe that's just we're not using them enough, but just something to think there. All right, storage. I said Cloud Spanner is basically we're using this for all of our relational data. And I'm kind of a little bit fuzzy here, is we actually predate use of Cloud Spanner, so we have something that's almost like Cloud Spanner, but not. But we love it. We have like no downtime for our schema changes, really no downtime for anything. Some lessons learned here, I guess. I was talking about schema changes is there's still a pain as far as like an app writer. It's still our biggest pain point. We haven't found a magic solution for that. Other kind of thing is if you look at the different modes you can set up Spanner in this, like I would say go to multi-regional first. If you're thinking is that we had to re-architect things in our app a little bit when we wanted to go multi-regional. Multi-regional actually slows down your commits. And for various reasons, we have in the app what we call little green dots everywhere that show whether or not you've read something, like a new comment. And what that meant is that as you're navigating around our app, things that should be read-only views actually become writes to Spanner, and we were doing those inline. And so when we wanted to go multi-regional, the transactions for those became slow enough. We had to do a little bit of re-architecting, and your app writers get unhappy when your database people make everything slower for you. So I would say bite that off first. What else? Cloud storage. We're using that lots of places. I mentioned testing already. In app, we use this for all like the resumes people upload, company logos, cover letters. And we actually use it for all of the static assets that go as part of our web page, like the CSS files, the HTML files. We love it. No real problems here. Maybe one like lessons learned here is I was looking at like the load time of our app versus like the load time of the main Google page. Why are my CSS files taking so much longer than Google.com's CSS files? And turns out I'd enabled the multi-regional cloud storage, but had not turned on the cloud CDN in front of it. And so the multi-regional, if you read it, it kind of seems like that's all you need, but if you're actually serving up assets, you also need to enable Cloud CDN as well. That's an easy change, though. Oh, memory store. This is, at least at the time I wrote this presentation, it was in beta. I think lots of things are being announced, so I'm not sure if that's changed today or not. We're really interested in moving some of our internal caching over this. Lessons learned here is that we're definitely not switching over to it until it's out of beta. There's a reason services are in beta, so believe that. Network. Notice the nice slide. A colleague and I were actually trying to talk and figure out what should we put on this slide. And his quote was, oh, the nice thing about this is, or the praise here is we don't actually have to talk about this at all, it just works. So we have, again, a relatively simple networking. We're using the Google Cloud Load Balancers, SSL termination. We're actually still single region right now, so that makes things a bit simpler. We've prototyped what we need to do for multi-regional, and it doesn't really change anything. So network, we're really happy. If I have to complain about anything, I would complain a tiny bit about Cloud CDN, as I wished it had a better invalidation API, is that you can invalidate things in it, but you can't actually make it part of your normal workflow. And there were a couple places where I wanted to have very long timeouts on some of our static pages and just rely on invalidation when they changed, and can't do that, at least not yet. Another quote from my coworkers, he talks about magic tools, and the one he always brings up is, I guess, Splunk, about how for certain things it just makes life so much easier. So I thought I'd talk a little about like what are these magic tools, the things we just love. So first off, BigQuery. I love BigQuery. We've talked about how to use it for tests. We actually throw all of our performance stats into BigQuery. And what we do, like an example of this is if you're in the browser, there's this window.performance APIs you can use to get things about like page load times and how long it took you to download each of the individual assets in a page. It's all available in the browser, and we actually send those over the server, shove them into BigQuery. And this is really useful. So, like, example where we used this was a while back, and it was, I think, after hours, and our users mostly use our app 9 to 5, and so you can see like anomalies easier at those times. And we saw this big spike in page loads, where they went, usually it's a small number of seconds or less, and they went up to like close to minutes. And that's crazy. So we dug into that, and turns out we looked at our stats, and yes, we were actually getting. There was one user had a handful, I think 100+ page loads that were taking over a minute, and when they should normally take under a couple seconds. And then we did the join against our backend data, which we also have dumped into BigQuery. And the backend, everything was fast. We started looking at all the network downloads for the individual assets. All those were fast. And at this point, we started like scrambling. We said, oh, what? Like we realized, oh, there's a new version of Chrome that just came out. It must be that. Turns out it kind of was. Is that Chrome had either updated or slightly modified how they throttle tabs in the background. It turns out this user had opened one of our list views, and on every single entry in there had clicked open in a new tab. And all those tabs opened, ran long enough for us to get like the start of the page load measurement, and then got suspended. And then when the user finally ended up clicking on one, they'd finish the page load. And since this user had opened up hundreds of these, by the time it got to the end of them, many of those had been sitting there for quite a while. And so this was, again, okay, it's easy. We can get the time backgrounded in our stats, push that through and avoid these, or just ignore these in the future. The bigger thing here, though, was actually like, why is this user doing this? And it turns out, well, we should have bulk actions. And from this we know, okay, let's implement a bulk action for that. So we love BigQuery. Other things in here for like lessons learned is we were initially using a Stackdriver logging sync to get the stats from our log files into BigQuery, and on our performance test setups, that turned out to be we were actually losing a fair number of logs that way. It was actually a fairly high performance cost, so we actually switched and started calling the BigQuery APIs directly, and since then we've had no problems. The thing with BigQuery, if you haven't used it, it integrates really nicely with Data Studio. It makes it really easy to spin up like dashboards, so we have that happening all the time. As like developers ship some performance improvement, they'll quickly spin up a Data Studio dashboard that shows, look, that things went like that, or more normally, I did this improvement and nothing changed. But yeah, Data Studio. Something to keep an eye on is queries can get expensive. We're part of Google, and I tried to figure out how much it was costing, and couldn't actually figure out how much BigQuery was costing us. So but yeah, so something to keep an eye on. But what else? The trace. There's a number of, this is also just very cool. It basically shows you how long a request took, and kind of each hop in the request as it goes through multiple app servers or backends, how long it took. You do have to integrate with it a little bit, but for a certain class of problems, it was just the tool that worked. Let's see, Cloud Pub Sub, another thing we just love. We're like a client of this for some of the public Gmail APIs where we get a message kind of for each new email coming in. We also use this internally for sending data to our indexers for like full text search, basically. And the failure modes for this are great. It's easy to use. It was something we should use more. Yeah, so if you've used our app, we look like a first-party app from Google. You're kind of indistinguishable from the other Google apps. But we're actually built using basically all of the public APIs that any third parties can use. And so what do we use? So I talked a bit about BigQuery, talked about Cloud Pub Sub, Cloud Storage. We use the key management service. This basically lets us get crypto keys out of our source code. I mentioned you should be checking all of your configuration into your source repository. And if you do that, what do you do about your crypto keys? You don't want them there. You can go like search on GitHub and find all these people have published their crypto keys for the entire world to see. You don't want that to happen to you. So key management service lets you avoid that. The other big one we use here is Cloud Talent Solutions. That was, I believe we have a talk here on Thursday. I think it's MLAI 108. You should definitely go to that talk. But what this is, we use this for all of our in-app candidate searching. And we went through a bunch of iterations here from just doing kind of straight up spanner queries for search in our app. Then we switched to using Solr for free text search. And we actually switched to another kind of internal Google thing for free text search. And then at that point realized actually search isn't our problem. it's not like just matching. If you're trying to search for like candidates, jobs, skills, those kind of things, is that you need something smarter. And that's what this is. The example they would bring is if you're searching for like an executive or an executive assistant, those are very different. And you don't really want searches for one to show the other, but if you're doing naive free text search, they do. And so this Cloud Talent Solutions solves all those problems for you across all industries. And it does things like, I think it's even smart enough to know that if you type in like, like military job titles, it knows how to map those to civilian job titles. And I think it's job titles, locations, skills, and a number of other things. So definitely check that out. Check out that talk. How do we actually integrate with this? Our app just inline makes direct API calls out to Cloud Talent Solutions. We're actually using Cloud Pub Sub to send whenever we get like a new candidate, new resume uploaded in our app. We push it into a Cloud Pub Sub, have separate workers that pop it out, and then make the API calls to add those to Cloud Talent Solutions. Another place we're using Pub Sub. Really like it. Let's see, what else? We use Sheets. A quote from like the tech lead of the Sheets team, talking a little while ago, was that Sheets is the second best tool in the enterprise for doing anything. And our users they really love Sheets. And so we've been focusing on doing basically full data exports to Sheets, as well as for some of our in-app reports, basically a cooked version of that report data to Sheets. And this lets our users modify the report, build their own reports and do some modification. As we get lots of requests for, we like this report, but I need to actually change a little bit, that person wasn't actually hired by me, it was hired by this other person, even though in the system, all sorts of excuses. They want to be able to edit the reports before they actually show them to other people, and we didn't want to build that in, so we put that into Sheets. Drive, we use that for basically any place you upload a file in our app. Gmail, we're doing two things there. We actually have a Gmail add-on, which basically lets you see hiring data about it directly in Gmail, so you can have seamlessly, if you're corresponding with a candidate via email, you can see what we know about it and hire there. Anyone can write one of those. And we're also using the Gmail APIs to basically ingest email conversations between people on the hiring team and the candidate, so you can view it in our app. Some lessons learned on Gmail. Gmail has 1 billion users, lots of servers, and it's totally willing to do a denial of service attack against you if you're not ready for it. Also, just some of the data shape can be weird, is that we kind of expected, we'll have any given candidate will have a few hundred messages associated with them between the hiring team, and you can get it to the point where, especially some people have hundreds of thousands, and if you're not ready for that, that can be a problem. Calendar, done a lot with Calendar there. We've actually built what we call a multi-slot scheduler. If you look at the interview day, it's one person meeting a bunch of people in a bunch of rooms. And so we've built this multi-slot scheduler. It's actually bidirectional sync, so you can, in Calendar, you can like adjust an interview schedule and it will reflect in our app and vice versa. And all of this is built with the public APIs. And here's a quote from one of the engineers on this is, don't do it, calendars are really hard, all sorts of crazy corner cases. That's true, but it's by far our most loved feature, so definitely do it, just realize what you're signing up for. These APIs are powerful, and calendars, you might think they're simple, they're not. You have to deal with non-Google calendars, time zones, weird configuration settings, permissions, spam filters. I don't know, so we thought it was going to, or more if you're doing stuff with calendar, just realize that the APIs are really powerful, and what you're going to get is going to look so seamless that your customers are going to want you to provide support for calendar. And we're part of Google, and we actually have trouble is that with the internal access guidelines, there's no way I can help one of our customers debug a calendar problem. That's some other team. And if you're outside of Google, that's going to be a problem as well. And one last lesson learned here is that once you start entering the calendar, your tests have time in them. And once you have time in your tests are going to fail on like New Year's Day, New Year's Eve, leap years, leap days, daylight savings time. I live with it. It's kind of annoying. Let's see, lessons learned. In the past several years, I've learned way more lessons than I can keep track of. Here's a top couple, and some of them are going to seem really obvious, but since they're things I had to learn, I might as well talk about them. So this is automate everything. People screw up. And at least if your software makes a mistake, you can write a test, fix the bug, file the bug, fix it, it won't happen again. You can't really do that with users. And so I'm claiming that we built a wildly successful application with happy users, and ways we've actually screwed up is we've deployed ancient builds to production, as in like months old. We deployed builds we hadn't qualified yet to production. I might say we've done most of these before we did that, and that my journey of those 4 slides is most of those were prior to our endpoint we are now. We've actually destroyed our entire staging system more times than I can imagine. This is the case with luckily is all of our servers are stateless, all the configuration checked in, it's really easy just to deploy it again. We've actually destroyed all of our production app servers. We almost use this as a troubleshooting problem. Sometimes something weird's going on, just kill all the app servers. Like the whole turn it off and turn it on again thing. It still works. We've actually I think this was before we had paying customers. We actually did destroy all of our production system once and had to restore from backup. The other thing here is at Google we practice what we call blameless postmortem culture. And this is where when like someone screws up is you don't say, hey, you're fired, get out of here. You say, okay, you need to write up a postmortem about what went wrong, talk about what went wrong, where you got lucky, where you got unlucky, and then list a set of action items to prevent this from ever happening again. And usually those are automate. Another quote from my colleague Bo, test that your backups work. Everyone knows this, only 10% of teams do this. And yeah, everyone knows this. I would say, test that your restores work. Who cares if the backups are going okay? And I did say we have actually had to restore from backup. And it might have been me, I'm sorry. But luckily you can always keep your existing database around and figure out what happened during that interval and replay it before customers show up the next morning. Yeah, definitely test your backups. Let's see. I say lame duck mode, that's kind of an awesome duck. But what this is it talks about when you're doing either a rolling update or scaling up, scaling down, is how you deal with requests to your existing app servers or the app servers that are being torn down. And it's one of those things that goes, oh yes, we should do this, we'll get around to it. It's one of those things, but it's not a big deal. And so we ignored it for a really long time. And then what happened is, somewhat embarrassing, is our sales team came to us and saying, we're running these demos and every once in a while things slow down and get really slow and it gets awkward because they run out of things to talk about. And if your sales team is saying that they're running out of things to talk about, that's definitely a problem. So what we did was we had actually been tracking what our P99 page loads and all those looked good. And so then we dug some more and said, okay, actually no, the salespeople aren't lying to us, things are actually slow sometimes. And a big portion of this was actually from how we were dealing with these rolling updates. An example of what would happen is if we were either, a new app server comes alive either from a rolling update or auto-scaling, is we were actually sending requests to it before it was ready to handle those. And then either they would fail and get bounced to another app server, or worse, they would hang out there and wait for the database initialization and other stuff to finish, and you get a slow request. Again, this is kind of super obvious things, and there's great support for this, we just weren't doing it. A similar one was as we were tearing down app servers, you'd get the cases a somewhat longer request would come in, one app server, get partway done, app server would get killed, it gets sent to the next one. Since we were rolling updates, it could sometimes bounce between multiple app servers. And so kind of embarrassing. And so the things here, again, it's all in the documentation. Do it. If you're using Kubernetes, you have a readiness check. Make sure your readiness check is actually correct. I think our first version of that, we were reporting readiness when we thought we were ready, not when we were actually ready. There's liveness checks you need, you can implement, and what else do I have here? Oh, I guess also if you're looking in Kubernetes, make sure you have a SIG term handler, and then also look at your configured connection draining timeouts. Those also matter here. So this is something we actually, another place where CloudTrace really helped us, is looking at these individually really slow requests. All right, last but not least is have an awesome design and product team. I probably should have said this first. It doesn't matter how technically awesome your application is if ordinary humans either can't figure out how to use it or don't want to use it. This is something that Cloud Platform is not going to help you with right now, at least until the ML and AI teams get their act together. So you really need good product and design people. And I know this personally, is our first couple versions of Hire, we actually didn't really have a design team at the time, and they were pretty embarrassingly bad. They were designed by people like me, and nothing worse than realizing that the software you designed is awful. So don't let that happen to your team. Love your designers. And they totally didn't pay me to put this slide up here. All right, that's basically it. If your team is hiring and need help with the process, go to hire.google.com to check us out. If you're looking for a job, we're looking for back-end, front-end designers, product people, come talk to me afterwards.